Hello everyone. I hope you are doing fine, enjoying your time. So let's begin our session today on HarmonyOS. So before beginning, I'd just like to highlight our community, that is Application Library Engineering Group. This community focuses on open source component development, currently focusing on HarmonyOS and Android components. So today we will see more on HarmonyOS application framework and how we all can contribute towards making this community a wonderful community. So about me, uh, my name is Sharath. I'm a HarmonyOS developer. I work for Huawei. I'm a senior architect here. So that's about myself. So let's begin with our session. So today we will see a little bit on why HarmonyOS has an importance in the current ecosystem and what we all can contribute to make it to much better ecosystem. Right. Currently, if you see, there are a lot of devices that we all use. You have a lot of smartphones that all of us are using from quite some time. We have wearables, smart TVs in your car, we have head units. So this is how it is. The applications on top of this is also developing at a tremendous pace. If you see for smartphones, it's 4 million plus. For wearables, it's 20,000 plus, or smart TVs, it is 10,000 plus, and so on. Over a period of time, the projected highlight in the usage of these devices also is tripling in every year. So we can see that graph also from the left-hand side, how many billions of devices that we will use in our day-to-day life. And approximately by 2025, each of us will be having somewhere around 9 to 10 devices, IoT devices per person. Maybe it is your smart TV, your smart watch, your smartphone, obviously. There are multiple smart screens, smart tablets. So many IoT devices are happening around. So the need for application developers are more. And what happens to application developer in the current ecosystem? So if you see our current ecosystem, each of the platform or the type of device that you're handling, the device form, it has its own stack. It has its own UI logic. It has its own platform that you're using, or it has its own API set, and the different type of IDE, the integrated development environment altogether. So this challenges the developer to focus on developing a single application for all these platforms. So HarmonyOS is trying to avoid these by bringing and bridging the gap of developers and ecosystem and create a unilateral distributed operating system that can be used across all these devices. So it also helps user in a way where if a user is using one platform, on the other side, he starts using, he has a different watch and he has a different OS smartphone. The experience in both the devices are completely different. So we are unifying this experience and bringing it seamless experience for users. So what is Harmony OS by the definition of it? So it's a distributed operating OS, thinking of future, how in future the entire OS and smart devices will be used. For the end user, it integrates various smart devices and gives a seamless experience. For an application developer, which we all are aiming at to become. So it helps you develop application that can be used across all the devices. So you don't have to work on different platforms, different UI stacks and different information or APIs. You only have to make the application once and deploy it in all these device forms. For the device developer, that is the hardware developer, the component-based device helps him to tailor a particular device for different forms to help him use the resources to the core. So let us see a small video explaining what I said till now.
HarmonyOS is a future-proof distributed and smart operating system open to you as part of the initiatives for the all-scenario strategy. It will be able to run on 1+8+N devices in the future. For an end user, HarmonyOS adopts a unified software system that delivers consistent, smooth, and secure experience across your smart devices. For a developer, HarmonyOS adopts distributed technologies to integrate various smart devices into a super virtual device. Application developers can use this super virtual device to develop applications on different device forms, focusing on upper layer service logic without caring about device differences. Device developers can use the capabilities of multiple smart devices as needed and deliver a smooth experience through this super virtual device. As a whole new future-proof operating system, HarmonyOS aims to play a vital role in a fully connected, intelligent world. We look forward to you joining the HarmonyOS family and together with us, witnessing what an all-scenario smart ecosystem has to offer.
That was a brief introduction of what we are doing. So to explain a little bit more on what this super device, let's consider a few examples or use cases where we completely understand how a super virtual device works. So let us understand a use case where we see about device collaborations. So here we see this is already in place in multiple ecosystems, but this is a unified ecosystem where we can integrate multiple OEMs or hardware which has a seamless experience. So in our current scenario where we are looking in, here we have two devices. One is your smartphone and another is a juicer. So based on the recipe, it lets you know what are the types of ingredients and you need to pick up and use it and how much of time you need to run it. So it will provide you the entire recipe. On the right hand side, you can see there is a oven, micro oven. So where on a push of touch of a button, it understands and gives a configuration for the recipe to the microwave oven, and you can cook the recipe with ease. So all this is possible because of the integration between all these devices and the understanding of the device capability among the devices. So all these uses either a HarmonyOS SDK or a HarmonyOS itself to run this experience seamlessly. We will, in previous multiple sessions, we have explained all these examples more thoroughly. So here we will concentrate more on the next level of application development. But I will try to explain multiple scenarios in one go in this slide. So here we can see there are around 7 to 8 examples, use cases that we all face on a day-to-day life and how HarmonyOS helps in achieving it. The first one we can consider is a smart home, where we can see how the home devices are controlled using a smartphone. Here it can be your water purifier, your air purifier, your smart health equipment, your smart processing units, micro oven, all can be functioned and visualized and controlled using a smartphone, and all of them can be integrated as a single solution. When it comes to smart travel, so think about a navigation system or a music system where you are playing. Let's consider an example where you're playing some music and you entered your car for driving. Seamlessly from the phone, the music starts resuming playing in your car through your car head unit. And in the car itself, you can start playing it. And once you get out of the car, the controls can be even accessed in the smartwatch. So that kind of ecosystem can be developed in a travel space. In terms of mobile office, where you can collaborate with your tablet, laptop, and your smart screen in one shot, where you can share your Excels or presentations through your phone, do the editing and presentations with your tablets or your laptops. So in the education field, teacher can be using a smart board for showing the child what it is about, and she can also pose few questions uh, on the same course. At the end of it, the child can respond through a tablet. I think in the video also we saw this example. The same experience can be done through an entertainment system where you can have a collaborative experience where the screen or the bigger screen that you have will show the display to the user. The smart speakers can provide the experience which the smart screen cannot give. We all know the TVs cannot give so much of wattage of output compared to the subwoofers and the additional speakers that we integrate with. Currently, all this happens in one way. When you connect the output and input to one audio system, it will all be connected to a wired system. Here, through wireless system, we can all assign different input and output systems seamlessly. The same applies to a fitness system where the type of fitness equipment you have, let it be your smart bands or smart watches, collect the information of your workouts, and your smart weighing scale can update the weighing system, and together it can give a collaborative output how much of run you should do, how much of walk you should do to achieve your health goals. The same applies to social networking and shopping applications, how you share the screens. So how HarmonyOS achieves this? If you see, each of the device form has certain resources available in its forte. So if you take a smartphone, it has majority of the resources, screen, network access, camera, microphone, a CPU, GPU, and a navigation GPS. The smart screen at the same time has very less resources, but the main advantage of a smart screen is its screen size, right? So a tablet is more in terms of interactive, it is more interactive with the device. A smartwatch is more captures a personalized information from the user. It has a lot of sensors, accelerometer or a heart rate sensor or biosensors. So it gives a personal information. Together, when we take this instead of an individual device form and we take it as a device pool, it has a lot of resources under one. And the applications built on top of this resources can collaboratively, we call it as a super device application. So when we merge all the resources, the smart screen, the bigger, wider screen, the information or the GPU and CPU of a device, and the information exchange from a tablet, we get a much higher resource capability, which provides a collaborative experience for the user. So this is what we call it as a super device, where using the resources from earphones, tablet, PC, smart TV, wearable, HD, and with the use cases and with the technology of HarmonyOS, where it has a multi-device interaction, device collaboration, and one hop, we together make it as a super device. So this is all about the HarmonyOS introduction and how we can collaborate through this. So let us go a little bit further today and understand how HarmonyOS architecture is built on. So if you see, it is a layered architecture where it has, let us see from the down layer, where it has a kernel layer, where it supports multiple kernels, and it is achieved through a kernel abstraction layer, simply called as CAL, the hardware driver foundation and driver subsystem, which abstract the drivers, different drivers, and provides a single API to the system service layer. So when it comes to system service layer, you can see majority of the system services or the main usage of the framework layer is through the system service layer, where it has a distributed task scheduler, a data management, and RQI, the multi-language runtimes, are all present at this layer. Majority of the libraries and the system services here are in the native layer. Apart from this, we have basic software subsystems like the telephony, where you make your calls, the multimedia, where you use your video, audio, camera, DFX for your enhanced experience, and special software subsystems for specific device forms for smart TV or wearable or IoT devices, where we are seeing here. And you have a lot of hardware tools, that is your location, biometric, wearable detection or IoT hardware detection. Then comes our framework layer, which utilizes the framework system service API and creates the UI framework or application framework on top of which we develop our applications. So application can also be divided in multiple ways. The system applications, which is the core applications that are mandatory for any UI development. The home layout, if you are a mobile developer, you might have seen the desktop applications or the home applications, that will be part of the system application. Settings, the system UI, call application, messaging applications, so on and so forth. So, and this is our call stack or our layered architecture, which supports so many features and where we can collaborate. On the right side, we have an IDE and the tool chain through which we can integrate and develop the device applications as well as the application layer applications. So when we talk about device layer, it is more in terms of our IoT based application. Let it be our IR devices, our security camera applications, these things. When in the application layer, it is more of user centric applications where you create maybe a login application or a camera application or a photo editor. So these kind of things, we call it as application layer applications. So the application layer also we have projected in this format where it is dependent on 4 key components. The UI framework, what we saw just now, and we have ability framework, application framework overall, and the language compatibility. The uniqueness of HarmonyOS here is it supports multiple languages. It supports Java, C, C++, JS, TS, and RQI framework, which supports multiple language application development paradigms through which current existing developers who have a certain pattern or liking to one of the type of applications can start building applications from the word go, where the learning curve is very small. When you talk about the application layer, we usually call it as FAs and PAs. Here, FAs are our feature abilities, and which is our UI component of ability. Ability is nothing but functionality. And the PAs are the particle abilities, which doesn't have the UI. Maybe something like our background services, like our alarm system. Without having UI also, it wakes up every time because the service is running and the task is been assigned in background for it to use. So let us see few technical features of HarmonyOS. So the soft dbus, we previously saw one hop application where it merges all the hardware like Bluetooth, our Bluetooth Wi-Fi connections, and seamlessly connects to rest of the hardware equipment that we have and helps us to bridge this gap. We already saw an example of a smart home where we said how our devices are integrated together using this soft bus. It creates an internal network among these devices, which helps in achieving interconnection between the devices. We also have device virtualization. Let us consider a video call experience where you're using a smartphone and a smart TV, where the UI is or the video is established in the smart screen, and the smartphone is used for mic as well as a data connectivity. You can also think of the same experience with while playing game, where your phone becomes your player or a controller, where your TV is the one where you can use it for playing the device, playing the game in a full screen. The data management, distributed data management seamlessly connects multiple devices where you can share a photo from the phone or your camera, and it can be visualized in on a smart TV or a tablet. The distributed scheduler is another part where it seamlessly changes the UI or the control based on the need of the user. We saw a music player experience. Here we have a navigation experience where initially from home in your phone, you can set a navigation to a certain location. When you hop onto your car, it seamlessly changes the navigation from phone to your car head unit, where it shows from where to where you need to go. Once you park your car, you need to still reach a certain destination that can be handed over through your smartwatch. So the distributed scheduler helps in scheduling the event or the feature abilities from one device form to the other device form. Collaboratively, all these things are making the device, these devices as a super device. So let us see a little bit of framework. So here is where most of us are interested in, and in the coming days, we will be exploring how to develop application. So we will learn a little bit of framework today, and we will continue in the coming days a little bit more, where we understand a little bit more of these framework and try to address the issues that are solved with the current framework. So the HarmonyOS, in HarmonyOS application, we have different type of UI framework, that is a Java framework and the Arc UI framework. So in the Java framework, you can develop application using Java application, and in the Arc UI, you can develop using JS or TS language. So if you see in the top layer, the application, whether it is Java or JS, the framework remains the same. It understands the language. Here it understands what kind of language you are working. And finally, to the UI framework, everything will be embedded in the final form in a similar way. The layout manager and the graphic control helps in developing an application for different device form. Let's say you have developed an application for a phone. The same application without changes will seamlessly work on a smart TV as well as a tablet. So in the current operating systems that are in the market, this is not true. Here we have to depend on multiple frameworks and multiple UI stacks. So that is avoided with the single framework of HarmonyOS. So as I explained, there are two different frameworks, the Java framework and the UI framework. The Java framework, in the last year, we focused mainly on the Java framework and the component development. This year, we will primarily focus on Arc UI framework, the concept where it supports JavaScript and the TypeScript for our development. So let us see a little basic concept here. Here we have usage of words like components and pages. So what is a component? The component is the simplest or a smallest unit where it shows the UI through which you can interact with the user. It can be very simple thing as like a button or even a text box. So that is our simplest component. So these components can also be used with flexible layouts. So together with the layout and all these containers that we have, we call a simple UI as a page. So in a Harmony application, it can have multiple pages which will form a single application. So we use different types of APIs for accessing it. We use routing mechanism like in web applications to move from one page to another page. So the key capabilities of Harmony framework or the RQI framework are, it has diverse components. It comes out of the box with multiple components like the text button, the grid layout components. It also comes with media components where you can use these components for media player, viewer, editor. All these components are readily available. There are many flexible layouts like the web components. We apart from the regular animations, it also provides us transition animations and attribute animations where you can control the animation with very granular level. It provides a lot of UI interactions, multimodal inputs. So the swipes, the double taps, all these things are covered through interaction. When you see the drawing, it is more like how you can lay down, uh, write images, shapes, and all using drawing component. Majority of the framework developed this at a later point of time. In the RQI framework, it is open from the very go, where you can implement applications like photo editors, uh, some of the artistic applications where you can draw images. These things can be achieved using drawing APIs. And we have platform channel, API channel, where through which it allows you to access the hardware sensors, uh, some of the components of system service what we discussed. These things are accessed through the JS application through the platform API channel. So here it's a little bit about in depth of RQI framework. This one we will explain again. Today is the first day of this description, so it might be a little bit too much, but I will explain today and we will have another session on the same thing to understand a little bit deep again. So the RQI comes up with two development paradigms, that is the JavaScript framework, where you develop application like in web with three components like HTML, CSS, and JavaScript itself. In TypeScript, it is more of component-based declarative programming language. So this is used for developing large complex applications where you have better state management and better, it basically follows OOPS. So in this way, in the current programming language front, TypeScript is usually preferred for large complex backend programming, and JavaScript is usually developed for front-end simple UI programs. So in our HarmonyOS, we have these two options where people who are already familiar with JavaScript and TypeScript can pick up the framework much faster and start developing applications. On the right hand side, we can see how both these languages are available, and this is our TypeScript development paradigm. The engine components combine provides these features that we discussed in the previous slide: a UI component, the layouts, animation, drawing, interactions, UI interactions, and the platform API. The Arc compiler and the Arc UI runtime helps in executing or rendering all this uh, application code onto the UI. We also have a small lightweight rendering engine which is used for rendering JavaScript and TypeScript. And we have a bridge layer and an adaptive layer which can be ported for different hardware and different platforms. The tool chain is the one that is used for compiling different cross-platform applications, where a JavaScript and a native language also can work cohesively in one application. This is a brief introduction of our session today about Harmony. There will be further training topics that we have lined up where our team, the first one is about the JavaScript and TypeScript training links. Our team will provide a list of trainings, both of JavaScript and TypeScript. It's more than 20 sessions. You guys can cover this. Our team will shortly provide all the information to you. And also we have our Discord channel where we can discuss about all the more information that we want. And then we will go with the basic component introduction, where we will see the skeletal of each application, how our application is built from the scratch. It is the getting started application. Then we will cover about the page, service, and data ability, how each of these can be realized, how a UI is developed, how a backend service is developed, and how data is stored and accessed across the application. We will also see how basic components are developed in TypeScript. We have extensive set of components. So we will try to see how each of these are used in an application and what are the different features that we have. And next comes a container application. All these basic components independently cannot be used, right? So it needs a basic container like a list or a row or a column where you place all these components and it will be listed. So these kind of more complex containers we will see in the container sessions. And when we come to animation, we will also understand why animation is needed and how it is helpful for making an application better, and how we can use transitional animations for moving between the pages and how to access these features for better user experience. In terms of hardware access and system API, for any application in one way or the other way, we need a hardware access. The hardware access might be primarily for maybe for I need a navigation lat long, I need to know where to locate myself in the map. I might need my accelerometer for using that to understand the speed in which I'm going, how I'm inclined. I need my compass to understand more information. How the system APIs will help me install an application, uninstall an application, give certain battery statistics. So all those things we will learn. Then comes a very important thing, the aim of our community as well, the library development. With all the knowledge, how we can develop libraries or components that will be useful for many developers like us. So we all can develop library components. Let us take a very simple example. Like we all in one or the other way would have used some feature called login, right? So all of us would have used a login page. So you would have seen some of the logins are consistent. If you see a Google-based login, irrespective of which, whether you're using web, your phone, Android, or an iOS or a Harmony, you will have similar experience of how a Google login is. So this is achieved using components. The same way, your connection to a cloud or your AI/ML model, these things run consistently across all the devices. So these things are achieved using components again. So let us see how these things we will do and increase the usage of our components by all developers of Harmony. Then we have some interesting features like how you can contribute to our open source. To do an open source contribution, what are the code qualities that we look forward? What are the static tools we run? How we will make our code quality better, and how we will avoid vulnerability, how we will test our code, how we will develop sample applications. All these things we will learn. Then we also see few advanced topics where how a Java and JS programming applications can work together in a simple Harmony application, where the features of an existing Java component can be accessed by the JavaScript application and can decrease the development or deployment time, and it can be ready to market. The same applies to JS and native interaction, where native here, when I say it is a C++ libraries, where all these interfaces are exposed to JS using mapping. And we will see how this can be done. And some of the old traditional libraries also can be ported to our existing ecosystem. So these topics will be something that you all should look forward, which will increase your understanding. It also has a lot of code labs, samples we will provide, and some of the assignments which will help you improve your understanding on HarmonyOS. So with that, I've covered majority of the information intended for this topic. You guys can connect to us through many of our channels. We have a Discord link, our social link, where you can connect to us, be part of our community, where we can discuss. I am also actively available on Discord channel. Our GitHub, where our existing components are available. You can look forward to all the content and material in that. Our YouTube channel, where majority of our previous trainings are available. Our LinkedIn, where we keep posting the latest happenings in all the other channels. If you have any information that you need more, you can always email us. I hope you guys have enough questions for me. I'd like to answer them. Please take up this opportunity to clarify. JavaScript, as I said, is most suitable for developing applications like widgets, small UI, less complex applications or components. TypeScript is we can use it for more complex applications. It has, like I explained, it has state management, which will help us build complex application, making it much layered approach.